In this video we will learn what is shear force and what is moment, and we will learn how to draw shear force and moment diagrams. In the next upcoming videos we will do beam examples, truss examples and frame examples for drawing these diagrams. Shear forces are forces that are perpendicular to the longest dimension that a structure has. In this beam over here, the longest dimension is marked with these yellow lines. A shear force is a force that is acting perpendicular to that line. For example, these red arrows over here. If we were to draw a perpendicular force to this axis, then this would not be a shear force, it is called a normal force. When a shear force is acting on a beam, it will create internal forces within the beam to make the structure stable and to try to withstand this shearing force. So in this example we can see a red arrow is the external shearing force, and it will create these internal forces that are trying to make this beam not to cut in half. And these internal forces are illustrated in a shear force diagram. So all a shear force diagram is it shows the internal forces that a beam has at any location. In this example we have a beam where a 10 kilonewton shearing force is acting on it, so a support has to have a reaction force worth of 10 kilonewtons to withstand that. And the way we set up our axes is the way that the x-axis is this one, and when forces move to the right they're positive, and when forces move to the downside they're also positive, and we call this axis the z-axis. So in this case, firstly we can see that the first force when we come from the left is the reaction force 10 kilonewtons, and that reaction force creates an opposite shearing within the beam, and we can see that right where the beam starts the shear force jumps up to 10 kilonewtons, and then there is a whole lot of nothing within the beam, so the shear force will not change, and then we have positive external force acting on this beam, and this will create a negative internal force within the beam. So 10 kilonewtons minus 10 kilonewtons is 0, and the internal force graph will go to 0. If we were to have a force that is acting in this direction, then this wouldn't be a shear force because it's not perpendicular to the longest dimension. Therefore, it does not affect the shear force diagram. Next up, let's move on to moments. A moment is equal to the force times the distance that is perpendicular to that force. So for example, we have this force over here. When we want to find a moment right at this cut over here, we would multiply the distance, this distance over here, times the magnitude of the red force. And notice, if we were to want to know the moment, for example at this point over here, let's mark it as point L, the moment would be much smaller because the distance is almost 2 times as small. To withstand moment, beams will have normal forces within it. A normal force is a force that is parallel to the longest dimension. So normal forces are parallel to these dimensions, and I've tried to draw these as parallel as I can. So when we have a force acting on a beam, the beam will bend, just like in this example. We have a force over here and the beam will bend, and this is what moments will do. The bending is caused because of the moments, and to withstand these moments, beam will have stretching at the bottom in this example and compression at the top, and this will create compressive normal forces marked as yellow arrows in this 3D cut, and it will have opposite forces within the beam marked as orange arrows at the bottom. What is also interesting to notice is as we move closer to the middle, the magnitude of these normal forces will decrease, and right at the middle, the normal forces that are caused due to bending will be equal to 0. So let's look at how to draw a moments diagram to this beam. We draw a moments diagram to the side of the beam or a column where the fibers of the beam or a column are stretched. So the moments diagram has to be on the lower side of the beam. The second thing that is important to notice is that the extreme points for moments diagram are located right where the shear force diagram crosses the 0 line. In this example, the shear force diagram crosses the 0 line over here, right where the force is. So let's start with the first way of calculating moments diagram. We can get a moment diagram when we integrate the shear force diagram, which essentially means that we calculate the area of each shape in the shear force diagram. We have two shapes in the shear force diagram. We have this rectangle, positive rectangle, and a negative rectangle. And the way we calculate the area of a rectangle is one side times the other side. So one side is 5 kilonewtons, and the other side, which is the length of the triangle, this is 3 meters. 3 times 5 is equal to 15. Area of second rectangle is equal to 15 times 1, which is also 15, but since it's negative, we just subtract that area from the first area and we get back to 0. And the second way to calculate the moment diagram extreme points is to just cut the beam at the point where we know that the moment diagram is going to have an extreme point. Cut the beam in half, and we'll just look at one side of the beam. Let's look at the left side of the beam. So 5 times the moment arm, which is again 4 minus 1 meters, which is 3 meters. And we don't have any other forces. We do have this 20 kilonewton force right at the cut, but since it doesn't have any moment arm, we can, I guess we can write this force. It's 20 times 0, but generally we will not write a moment that has a moment arm of 0. So this comes to 15, and we have to use the knowledge that we draw our moments diagram to the side that is stretched, and yeah, to prove that it goes to 0, we can also now look at the right hand side, and we should again get the same answer, which is 15. So 1 times 15 is indeed 15, and 15 minus 15 is 0. So this is how we draw a moments diagram. In the next couple of videos, we'll do some beam examples, truss examples, and most importantly frame examples, because frame examples are the most complicated, and even I from time to time tend to make mistakes there. But for now, that's it. Comment down below if you couldn't understand anything, or if you have any other things that you like to say, or like me to explain, and I'll see you guys in the next video.